Nenomatica, where mathematics meets YouTube excellence. In this lesson, we solve a rational inequality exactly by the case method, mirroring a classic algorithm. We will follow the steps verbatim and emphasize every change with a bright highlight. First, we display the example and the exact statement in bold orange label. Step 0. Domain. The denominator cannot be 0. We record this rule. So we require a 2x plus b2 is not equal to 0, which implies x is not equal to negative b2 over a 2. Step 1. Case 1, when the denominator is positive. We multiply the inequality by a positive factor. The direction stays the same. Start with the system. The original inequality, together with a 2x plus b2 greater than 0. Multiply both sides by the positive denominator. We conclude a 1x plus b1 greater than 0, together with a 2x plus b2 greater than 0. Step 2. Case 2, when the denominator is negative. Multiplying by a negative number reverses the inequality. We write the system with a 2x plus b2 less than 0. Multiply both sides by the negative denominator. The sign flips. We obtain a 1x plus b1 less than 0, together with a 2x plus b2 less than 0. Step 3. Combine the cases. The complete solution is the union of those two systems, with the domain restriction that a 2x plus b2 is not 0. In this lesson, we will solve a rational inequality by splitting into cases based on the sign of the denominator. The problem is left parenthesis 5x plus 4 right parenthesis over left parenthesis 3x minus 2 right parenthesis is less than or equal to 0. Strategy. The sign of a fraction depends on the signs of the numerator and the denominator. We will consider two cases. Case 1, the denominator 3x minus 2 is positive. Case 2, the denominator 3x minus 2 is negative. Case 1, assume 3x minus 2 is positive. Because we are about to multiply the inequality by a positive number, the inequality direction stays the same. We get 5x plus 4 is less than or equal to 0. Solving these gives x is less than or equal to negative 4/5 from the first inequality, and x is greater than 2/3 from the assumption. These cannot both be true at the same time, so there is no solution in case 1. Case 2. Assume 3x minus 2 is negative. Now when we multiply both sides by a negative number, the inequality reverses. So we obtain 5x plus 4 is greater than or equal to 0. From 5x plus 4 greater than or equal to 0, we get x greater than or equal to negative 4/5, and from the assumption we get x less than 2/3. Combining gives the interval from negative 4/5 closed to 2/3 open. Let us visualize the answer on a number line. We mark negative 4/5 with a filled dot and 2/3 with an open circle and shade the region between them. Conclusion. We split the inequality into two cases based on the sign of the denominator. Case 1 provided no solutions. Case 2 gave the interval from negative 4/5 to 2/3, including the left endpoint and excluding the right endpoint. Therefore, the solution set is left bracket negative 4/5, comma, 2/3 right parenthesis. In this video, we will solve a rational inequality step by step, following the exact structure shown. First, we display the example label. Step 1. Rewrite the inequality so that 0 is on one side. We use the rule for inequality manipulation. Start with the original inequality. Subtract 2 from both sides to form a single expression greater than 0. Step 2. Express the left side as a single fraction using a common denominator. Combine the terms over the common denominator 3 minus x. Now expand the numerator and simplify the numerator to get the reduced rational form. Step 3. Analyze signs to solve the rational inequality. We split into cases based on the sign of the denominator. Case 1. When 3 minus x is positive. Multiply both sides by the positive denominator. The inequality direction stays the same. Solve for x and also include the denominator condition. Combine the two conditions for case 1. Case 2. When 3 minus x is negative. Multiply by a negative quantity. The inequality direction reverses. Solve and compare with the denominator condition to see there is no overlap. Step 4. Write the final solution and visualize it on a number line. The final solution set is the open interval from 4/3 to 3. Now we confirm on a number line and shade the solution region. Quick challenge. Pick a value inside the interval like 2 and a value outside like 1. Evaluate the original inequality at each to verify the truth value. Summary. We rewrote the inequality, combined into one fraction, performed sign analysis with cases, and stated the final solution with a number line visualization. Rewrote the inequality, combined into one fraction, performed sign analysis with cases, and stated the final solution with a number line visualization. Example. We will solve a rational inequality step by step. Our problem is the quantity 5x minus 3 over the quantity 2x plus 7 is less than or equal to 5 over 2. Step 1. Subtract 5 over 2 from both sides to set the inequality to 0 on the right. Step 2. Combine the fractions using a common denominator 2 times the quantity 2x plus 7. Step 3. Distribute and expand the numerator. Step 4. Combine like terms in the numerator. 10x minus 10x cancels, leaving negative 41. Since the numerator is always negative, the sign of the fraction depends entirely on the denominator 2 times the quantity 2x plus 7. We now split into cases based on the sign of the denominator. Case 1. Denominator positive. That is, 2 times the quantity 2x plus 7 is greater than 0, which means 2x plus 7 is greater than 0, so x is greater than negative 7 over 2. When the denominator is positive, multiplying both sides by it preserves the inequality. We get negative 41 less than or equal to 0, which is always true. Therefore, every x greater than negative 7 over 2 satisfies the inequality, except x equal to negative 7 over 2, which is excluded by the denominator. Case 2. Denominator negative. That is, 2x plus 7 is less than 0, so x is less than negative 7 over 2. Multiplying an inequality by a negative flips the direction, giving negative 41 greater than or equal to 0, which is false. Hence, there are no solutions in this case. Therefore, the overall solution is all real x greater than negative 7 over 2. Let's visualize this on a number line. Recap. We brought terms to one side, combined into a single fraction, simplified to a constant over 2 times the quantity 2x plus 7, and then used sign analysis. Case 1 produced all x greater than negative 7 over 2. Case 2 produced no values. So the solution set is the interval open at negative 7 over 2 and extending to infinity. Final answer x belongs to the interval open at negative 7 over 2 and unbounded to the right. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. Nenomatica, where mathematics meets YouTube excellence.